Okay, try this again. There we go. I'm just using a whiteboard, using my iPad as a whiteboard versus logging in. So we'll see if that impacts how we're able to do stuff here. Anyway, I did want to point out, if we go back to the notes, that I had a little bit of a notation problem in this one. This last example that we did last Tuesday. We can see here that my standard, this is my variance. Remember, the standard deviation squared is variance, and we have to square root that to get that back to a standard deviation. But if I look over here in my notation here, I have the standard deviation equals that sum, which isn't necessarily the case. That standard deviation is actually the standard deviation. So there's two ways to fix this. I could, if I wanted to, put this as a squared standard deviation, make it a variance, and then I'm good to go. That fixed my problem. But typically, because of we're wanting to get back to a standard deviation because that's what we're going to use, we needed to have this square root sign underneath there. So again, to clean that up a little bit as far as what we needed to see with that. This example 7 is very, very similar to that. So we'll just, as a memory refresher, here we go. As an extra source of income, the athletic department, K-State, is considering a new lottery-like scratch-off game called Wildcat Cash. It costs $1 to play. The probabilities of winning various amounts are listed below. Find and interpret the expected value when playing one game. And actually, if I also remember right, I think I when I was going back through this and giving my other lectures, I'm not for sure if I interpreted with you guys. I think the green writing, if you could actually read my green writing, is something I added afterwards. Um, so make sure the typical articles of clothing purchased at the buckle from the salesman is 1.84 garments on average. So again, we're writing out that interpret statement, as well as saying the typical deviation from the mean of 1.84 garments is 1.604 garments on average. So again, remembering those statements as far as describing mean and standard deviation, I'm not for sure if they were there when we took notes, because I probably failed. Anyway, so if we took the time and we added 1/10 through 1 out of 120,000, if we added those up, those probabilities do not add to 1 because there's one thing that we're missing. What are we missing? Why why don't they add up to 1? What's missing from this? Okay, there is a chance that we're not going to win anything. Okay, so we need to add so we need that outcome of winning $0. And this is where we would have to take 1, we would have to subtract, add these all together, subtract from 1 and find out what that is. I'm going to cut to the chase because we don't need to spend time doing that operation. That's going to be a 779. Okay. So, and actually, oops, they expect this part. That part of the problem is okay. I don't like earn. We're going to go with win. Technically, earn. If I had to pay $1 to play, my winning. In reality, this is I have a hang up on this problem all along. I should go ahead and change it in the front side. My winnings is it cost me $1 to play. So if I win $1, technically my winnings is going to be 0. And technically my winnings is going to be $1. So in the grand scheme of things, if we adjusted that, we could change it, but I'm just going to roll with the problem the way it sits, just the verbiage, and I get a hang up on the little stuff. Anyway, again, this is going to be our expected value, and expected is in that quotation marks because that's what we're finding here is an expected value. So if we wanted to, we could write this as the expected value of X. Okay, if they defined what X is. So remember, we just wrote down X. Did they tell us what X is? Anywhere up here? Well, they have the winnings of X and the probability. So I would say that is defined somewhere where X is going to be my winnings from the game. Okay, so if we remember from last time, we're going to take the outcome times its probability. And then we're going to take the next outcome times its probability. However, this is a laborious exercise that we would never expect you to do by hand. So we can put the dots in there. We can then just write the last term. we have 0 times 0.779. So that is going to get us to our expected outcome, our expected expected earnings. Okay, so luckily I have in my calculator, I think I should have all that in there. So if we come over here, as long as it looks like I have them in right, as far as list 1 is going to be my earnings. List 2 is going to be my probability of those earnings. So now if I want to find that expected outcome, so I'm finding a mean and I'm finding a standard deviation. So to do that, we're going to go to stat, we're going to go over to calculate, we're going to choose option 1. Okay, because option 1 is where I find a mean and a standard deviation. However, it's a little bit different with a probability distribution because list 1 is going to be my outcomes. List 2 is going to be the frequency, and that all stayed the same from the last time I ran this. So we can just hit enter, and okay then. Value entered is not allowed in a function or command. Well, let's see what I entered. Clear. I actually don't know what caused that. We'll try again. Stat, go over to calcula. List 1, list 2. Everything should be fine. I don't see anything in there that's going to cause that to go wonky. I don't know why b y equals. You dirty dog. I do not know what is causing you to do that. We'll quit you. Could not tell you, and I don't know if I want to take time to do that. So I'm going to bail on that. We're going to go back to my notes because I have it typed out from my notes. So we're going to go with 0.6 is going to be what that turned out to be if we saw that. I don't know. Maybe we didn't need to spend time doing this, but I don't want to figure out why it's not. I can do that next. You know what? I can do that during advisory. Okay, we're just going to go with the first example the way it is. So, sorry. Anyway, so the other thing that here was we need to find and we need to interpret. So our interpretation is going to be what then? Okay. The typical winnings from buying a Wildcat Cash scratch off game. Huh. I don't want to fit this. Is 60 cents on average. So I'm going to pay $1 to play a game where I'm expected to win 60 cents. So therefore we can see that I'm going to come out behind in the end on that. So I guess it depends on how many times I play that. What's our next one? Find the standard deviation of winnings and why is it so large compared to the expected value? So again, we would go back to my calculator, have no idea why that's not working correctly. But if we wanted to type that in there, if we wanted to, again, we need to write this out notation wise. So the observed value is going to be 1 minus the expected value of 60 cents. We're going to square that. We're going to take that times that probability of 1 in 10. Okay. Then we're going to have the next outcome, which was 2. So usually we just do the first 2. We'll dot, dot, dot that, and then we'll throw in the last term. And then we have to remember, again, notation-wise, we were talking about the standard. We're getting at 2 standard deviations, so we got to square root this. In any regards, that is 0.404 for $4.04 is my standard deviation. So again, they wanted us to interpret that. The typical deviation from the expected outcome of 60 cents is 404 on average. Okay, so the typical outcome then is $4 away from that. Now our question, the other question there is, why is that so large compared to the expected value? And again, we have to remember what makes standard deviation, the killer for making standard deviations large is going to be scale. And again, we're going to look at our scale where my expected winnings go all the way up to from 0 to 900 is going to be the scale. So we have a, so the answer to this question, and maybe I should put it in a different color, not that you guys get to write in different colors, but we'll underline that in blue. Why is it so large? Well, that's because we said large standard deviation because scale is large, 0 to 900. All right, so hopefully you had a chance to go out and grab the other document because we're going to jump over to it now. That was a probability distributions copy. Where's the original probability? Oh, it's not probability distributions. What am I searching for? Oh, look at all those. I had this pulled up, I swear. Okay. Sorry, we got to take time for Mr. Dottie to go get this. This is stupid. Thought I had everything. Okay, now that I put you all to sleep, by doing that, not that I hadn't put you all to sleep already. Here we go. So let's see if this works in the calculadora. After much, this is again the extension of another activity that I stole somewhere else. After much thought, the boss was fine, decided to give a permanent employee wages, which are randomly assigned wages. I'm sure that's good for morale. Assigned using the probability distribution X given below. So we have our variables defined X. Additionally, at the end of the year, she gives her employee an hourly raise. The bonuses are assigned with a Y. So assume that X and Y are independent of each other. Okay. We have a probability distribution. What's going to be my typical wage, and what's going to be the variance, and what's going to be the standard deviation. So again, it's going out and figuring out how to do this. If we're going to do the mean, that expected value of X, remember it's going to be, so we're going to take, and this one actually might even be faster to type in by hand, at least for the mean part. 9 times 0.3 plus 12 times 0.45 plus 15 times 0.25. So it might even be faster we got to type in all those numbers into our calculator anyway. So getting to the mean of 1185, that might be faster by hand. okay, but just because there's only 3 outcomes. However, if we were to get to the standard deviation part, that's going to be a little bit different. So I'm going to go ahead and put the square root sign first, just so I can remember what I'm doing. But anyway, that's going to be 9 minus 1185 squared times 0.3 plus, we should put that other term in there, but I'm running out of space. 15 minus 1185 squared times its probability of 0.25. So again, we kind of cut to the chase. So now we're going to go out to my calculator, and hopefully it's working right, because I'm going to be extraordinarily irritated if that doesn't come out. So my outcomes are 9, 12, and 15. The probabilities of those outcomes are 0.3, 0.45, and 0.25. So I have my outcome and the probability of each outcome there. So we're going to go back to stats. We're going to go over to calculate. We're going to choose a one variable statistic, L1 and L2. And I don't know what there was in that list. The original list that I had was wrong, but who knows? Anyway, there's the 1185 that we already said it was. We're after our standard deviation. So we're going to go down there to the 2.21, or actually 2.22. So we're going to come over here, and my standard deviation is 2.22. And so to get to my variance, we're going to square the 2.22. I actually don't think variance is not one of my options in there. So we have to just go ahead and square that by hand. So that's going to be 4.93. Okay. Hopefully you have a chance that you have a calculator handy. I would like you to try to do y, and we'll see what happens to that. If you don't, life goes on. But we're going to. You can at least write out what we need there. Okay. All right. So what's going to happen is this is the key part that we're trying to really get to. So far, we haven't done anything unusual with this, but now what happens is we're going to put two probability distributions together. So we're going to let n be the new hourly wage for the upcoming year, x plus y. So we're going to see what happens to this probability when we put two things together. So first of all, what are the possible new hourly wages? So I could have been given. I could have a wage of 9, and I'm given an increase of $1. So that means that 10 is a possible outcome. We could have 9, and we'd be given a $3 wage. So that means that 12 is going to be my next possible one. So we're combining, again, 9 and 3 together. So 9 and 3. So that's my two. I put those together. So now we'll do the same thing with 12. 12 and 1 make 13. 12 and 3 make 15. 15 and 1 give me 16. 15 and 3 give me 18. Okay, so again, it just as a word, if we're trying to remember things, that's another way to just to remember. My sample space is all possible outcomes. So possible wages is also called my sample space. Okay, just in case, again, this is understanding verbiage when we see it. What's the probability of an employee being assigned a $9 wage and a $1, excuse me, $9 wage and a $1 raise, if I could talk. So this is a probability of a $9 and a $1 raise. So the key up here is, and we could highlight this, X and Y are independent. So because X and Y are independent of each other, this now becomes the probability of 9 times the probability of 1. So this ends up being 0.3 times 0.7, which gives me a 0.21. So what happens is we can now find a distribution table for X plus Y. So where they've defined N as the combination of X and Y. So really what we have is we have the outcomes that we've already talked about. We can get a 10, we can get a 12, we can get a 13, 15, 16, and 18. Those are my possible outcomes. We can do the probabilities as we did before. So we just found out this is going to give me a 21. We could then multiply and find all the other ones, but we're going to cut to the chase, and I'm just going to write them in here. And now we need a mean and we need a variance and the standard deviation of this. So again, because we have that probability distribution, we're going to go out to my calculator. I'm going to go stat, we're going to go 1, and I'm going to drop these into a list of my calculator. Unfortunately, I really hate to kill class time with you just watching me enter data, but maybe it's an okay thing. All right, so there's 6 entries there. I have those. I'm going to come over here and change those probabilities. All right, so there's our outcomes and each of those probabilities. So we're going to go stat, we're going to calculate. And again, actually, it's still the same thing. I've kept using L1 and L2 all over again. So there we go. We're going to get a mean salary of 1345 and a standard deviation of 2.40. So my mean was 13.45. My standard deviation was a 2.4. If we square the 2.4, we're going to have a variance of 5.76. Now, here's what we're trying to grasp here, if we can. What if we come back up to here, and we're trying to compare, again, if I highlight this, I don't want we'll go with lime green, not that you can see. My first mean was 1185. My next mean was 1.6. Now, what is 1185 and 1.6 added together? Well, hopefully we piece together that if we add those together, we get 1345. So that means in reality, if I want to find the mean of n, I don't have to go through that process that I just did of figuring out all the possible outcomes, figuring out all the new probabilities. In reality, to find out what the two outcomes together is, all I had to do was add the mean of x together with the mean of y. That's all I had to do to get there. Okay. Now, here comes the harder part, the odder part. If I come over here and try to add standard deviations together, if I add 0.22 together with 0.917, so if I'm adding these two together, here's 2.22, the standard deviation, 0.917, the standard deviation, that is going to give me what, 3.13? something like that, but I have a standard deviation of 2.4. So what I have to realize is the standard deviation does not follow that process at all. And actually, we've talked about this before, but what happens is we can't just add standard deviations together. We have to add variances together. Okay, so if I took the variance of the two and added 4.93 and 0.840, if I added those together, I see that I have the 5.76. So again, when we talk about doing those things together, we can't add standard deviations. We can, however, add variances. And then to get from a variance to a standard deviation, all we have to do is square root that. So we have to remember this is going to be the variance of x plus the variance of y. Okay, so again, there's the key concepts. I feel like we took 5 minutes to get to something that was, here's what we need to know. We need to know that all we have to do is add the parts together, add and square root their variances. Okay. All right. So let's, hopefully you're kind of following through this. I realize I'm doing all the talking, but that's what happens here. So, all right. So just to help understanding not that this would ever happen to you, but what happens if we decided that we wanted to subtract the two? So again, we'll cut to the chase a little bit. So I'm going to take n is now going to be x minus y. So now if we went to the previous page, we're going to take that first outcome of 9 and we're going to subtract, excuse me, was it 9? 9 minus 1 is going to give me 8, but 9 minus 3 is going to give me 6. Okay, so again, if we didn't quite get where those came from on the previous page, I took $9 here and we subtracted $1 here, so that would be an 8. But when I take 9 here minus 3, that gives me a 6. So that's why 8, that's where we get those outcomes of 8 and 6. The same properties work as far as finding out what the probabilities are. So this is going to give me a 9. This is where the 21 goes, a 135. So those probabilities end up being the same. We're just rearranging them, and they're not quite in the same order as they were on the other page. Okay. So there is that. Now I feel like I'm really getting crunched on time, and that may be completely wrong, but just for this sake, I'll just go ahead and fill this in, because what I need to do now is I can still do it. Why not? So let's go out to my calculator. We're gonna go stat. We're gonna go number 1, except I'm gonna save those other ones. We're gonna arrow. This is going to be my outcomes of 6, 8, 9, 11, 12, and 14. Those are my outcomes. Again, the probabilities are 0.09, 0.21, 0.135, 0.315, 0.075, and 175. Okay, there's my probabilities. Now we're doing 3 and 4. So stats, again, we're finding a mean and a standard deviation. So I go over to calculate. We're going to choose that one variable statistic, but now things have changed because I have data stored in L3. I have the likelihood stored in L4, 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 the other L4. Oh, I don't have an L4. Well, that's stinky. So there it is, 10.25 and 2.4. What? 10.25 and over here, 2.4. That seems different yet the same. Let's square that to get 5.76. So now let's flip back and compare that to my results from the previous page. I can see that, obviously my mean was different. I got 10.25, but my variance is the same and my standard deviation is the same. So what's up with that? Now, if I go back and look again, we wanted to compare. I did the difference between x and y. So now I'm going to subtract these. So if I take 1185 minus 1.6, that's going to give me a 10.25. And if I scroll down here, sure enough, look at there. Here it is, 10.25 was the mean. So, that was a simple part of this. To get to the mean of this, the mean of n, in this case, n was the mean of x minus the mean of y. We just had to subtract their means. However, the weird part was that my standard deviation was at 2.4 whether I added or subtracted them. So that's the part that we have to remember, and this is the part that will trip people up when we go to find the standard deviation. Again, we're going to go back to using the variance, but we're always going to still add the variance of x together with the variance of y. So that's what I highlight that. I guess we'll highlight that too. Okay. We're always going to add variances, okay, because we're increasing the amount of variability that we have. Okay, so let's try one here. So this is the intent as far as well, we have cars sold, and again they gave us a mean and they gave us a standard deviation of that. So let's see what we can do. A large automobile dealership tracks sales and lease agreements made each hour of the day. Let X be the car sold. Let Y be the number of cars leased. Based upon the previous records, the probability distributions of X and Y are as follows. Okay, so all right, so this should be simple enough. Find and interpret. I don't want the highlighter anymore. Find and interpret the mean of t. So that means that we need to know what the mean of t is. The mean of t then is it, did it say let t be x and y added together. So that means that the mean of t is going to be the mean of x plus the mean of y. And so that is going to be a 1.1 was x mean, 0.7 was the y mean, so 1.8. We can go ahead and write in cars, but it wanted us to find and interpret. So that was the second thing. So we're going to give this a different flavor. Over many Fridays, the dealer expects to sell our lease $1.8 cars in the first hour on average. All right. Calculate and interpret the standard deviation of this one. So again, so now we're talking about the standard deviation. So we have to remember we want the standard deviation of t. And there's no sense in cramming this together. So I am going to erase that. I'm going to move it over here. The standard deviation of t is going to equal the square root of the standard deviation of x, the variance of x and the variance of y. So we're going to end up with well, we weren't given variance, so we got to remember to make that transformation. So we're going to square the 0.943. We're going to square the 0.64. And if we do all that, we're going to get 1.14 cars. Typical distance each observation lies from the mean of 1.8 cars is 1.14 cars. All right. Last one on this. Oh my gosh, this is dragging on today. Half of you are probably asleep. The dealership's manager receives a $500 bonus for each car sold and a $300 bonus for each car leased. Find the mean and standard deviation of the manager's total bonuses. All right, so we need to know the mean bonus. So that's going to be coming from the mean of sales plus the mean of leases. Okay. Or actually I should have gone X and Y, but that's all right. So since I introduced S and L in there, so that means that we would have to do S equals sales and L equal leases. Anyway, we don't have that information. However, I know that I'm going to make $500 for every car that I sell. So all I have to do is take this, all I have to do is multiply that times $500. So that means the mean of my sales is going to be $550. The standard deviation of my sales is going to be 471.5, as all we do is, again, multiply by 500. We'll do the same thing for leases. So the mean bonuses based off of leases is just taking this times 300, because that's all I'm making off of leases. So that means that we're going to get 210 for the mean. And my standard deviation of my leases is going to be 192. And now I'm ready to finish up this question down here. Did it find the mean? Oh, good. I don't have to interpret this one. That's the time killer. All right. So we have 550 is my typical earnings off of sales. 210 is my typical sales earnings, a bonus off of leases. So we're adding those together. So my typical bonus is going to be $760. The standard deviation of my bonus is going to be equal to, and we have to remember that we're going to do variances. So we have to take that 471.5 and we have to square that. We're going to take the 192, we're going to square that. We're going to add those together and we get $509.09. Okay. All right. Well, that was too much fun. We should do some more. Oh, wait, we are going to do some more. Here we go. Let's jump out to our notes. There isn't a whole lot with our notes here since we went through the logic behind that. Notes here is going to be much faster, especially if I just start writing things down versus typing them in my calculator. So we're going to go back to our Unit 4B notes key. We are moving over to transformation or transforming linear variables. Willie's Catback Car Offer Tours offers a popular half-a-day trip to various K-State attractions. There must be at least 2 passengers for the trip to run. The vehicle will hold up to 6. All right, so define X as the number of passengers on a randomly selected day. Find the mean and standard deviation of that. So this is very, very straightforward. We would drop this into our calculator into list. However, on the AP exam, we have to remember that we have to show the notation of that. So this is going to be 2 times 0.15. Plus 3 times 0.25. We're going to put our dots. Our last one is going to be 6 and 0.05. And if we do all that, that gives me a 3.75. The standard deviation of X. And again, we're using X because they told me they defined it as X. Is going to be the square root of the first X, 2 minus 3.75 squared times its probability of 0.15. I do not want to try to fit all those in there, so I'm going to go ahead and dot myself now. 6 minus 3.75 squared times 0.05, and if we do all that, we're going to find out that this is going to be a 1.09. Now, if we went back on the other one and looked at the, we found out on the other one that we had 300 for, sorry, I stumbled over myself so bad there. All right. Willie charges $150 per passenger. So that means if you've got 2 passengers sitting there in the catbacker, 2 times 150 gives me that $300 there. Okay. So that's where all those distributions came from. Now we've actually conquered this in a different chapter, Burke, in the previously in the semester, to find out the mean of what's my new variable? Let the random variable C. So that means it's going to be the mean of C. Okay. We don't have to do this as a probability distribution. We can just take by mean of 3.75, I make $150 on each of those 3.75 passengers. So I know this is going to be $562.50. So we didn't necessarily have to drop that in. I don't even know why I did that. Standard deviation of C. So again, standard deviation wise, again, because it's multiplication, we had a standard deviation of 1.09. I multiplied everything by 150. So again, that multiplication, everything just is multiplied. We get 163.50. Okay. So in that case, this was a skill from a previous chapter, but that's okay. Okay. So what we have to remember here is when we multiply or divide everything, okay, everything is affected by multiplication and division. Okay, doesn't matter. And again, that does not change the shape of my distributions when we get into those shape things later on down the semester. Now, it cost Willie $100 per trip to buy permits, gas, and athletic passes. So the random variable now is, so we started out with this $300 up here, but it's costing us $100 per trip for all that fun stuff. So when we take 300 minus 100, we're going to get the 200. So that's where that $200 profit came from. Okay. And again, we could figure this out and do a probability distribution and do all that fun stuff. However, all we're doing now is we are subtracting 2 groups if we wanted to. So now we have the mean. So we let V describe whatever V is. I'm not sure why we chose V. But the mean of V then is just going to be my mean of $562. That's how much I was making in profit, my previous mean, minus the $100. And that's going to give us a $462.50. And here's the kicker, the one we have to pay attention to, the standard deviation of V. Now we have to remember all we did was we subtracted 100 from each of those values. So all we did was we slid it down the number line. So we have to remember addition and subtraction has no impact on standard deviation. So it is going to remain the same at 163.50. Because all that happened is we changed this location on the number line. Okay. So adding and subtracting to affects center and location. Okay. Does not change the measures of spread. Does not change the shape. Okay, so that's what when we add or subtract, it's just going to affect our measures of center and location. All right, this is going to work out right time wise, I think. Unfortunately we still have 2 more pages of notes to go. So but unfortunately with time the way it is, I would love to stop right now because I think this is probably information overload point. However, we don't necessarily have time for that. So we're going to keep on trucking here. Okay. Combinations of random variables. So this is a little bit, we've talked about this as far as looking at my means and my variability. And again, the thing that has to be here is they have to be independent for this to be true. Okay, so we've talked about how to find a mean as far as taking the outcome times its probability. We've talked about how to do the standard deviation in the same way. So when we talk about putting groups together, all we have to do is add their means or subtract their means, depending on what I want to do. However, I have to remember over here with variance that we are going to add and we're going to add. So variance is always the standard deviation. We always add no matter what we do with the groups. Okay, and if there's any type of scalar multiplication, here it is down here. Okay, so we just, that was on the previous one where we got that $500 bonus, or we got that $300 bonus. So here it is. It's a similar style of problem. Let X be the number of passengers on Willie's Catbacker Tours. Y is going to be the selected on Jayhawk Adventures. Define T as X plus Y. Find and interpret the mean and standard deviation of T. Okay, so this is where we're going to cut to the chase a little bit. Okay, so if I did this, the mean of X turns out to be 3.75. All I'm doing is killing the calculator part to this, because this is just dropping 2 lists in your calculator and doing a 1 variable statistic on it. We get 1.09. Over here, we're going to have the mean of Y. Turns out to be 3.1. And the standard deviation of Y turns out to be a 0.943. And where they're wanting us to find the mean of T, which is going to be the mean of X plus the mean of Y. So my mean of X was 3.75. The mean of Y was no, it wasn't, it's 3.1. So we end up getting 6.85 passengers. All right, so is this per week? Yes, the typical number of passengers taking Willie's Catbacker Tours and Jayhawk Adventures is 6.85 passengers on average. Standard deviation of T is going to be the square root of the variance. So this is going to be the variance of X and the variance of Y. So this is going to be 1.09 squared plus 0.943 squared. And that's going to give me a 1.44. The typical deviation in number of passengers of Wildcat Tours and Jayhawk Adventures from the mean of 6.85 is 1.44 passengers. Okay. Example 2, Mrs. Sapp likes between 8.5 and 9 grams of Splenda in her coffee. Suppose the amount of Splenda is random in a randomly selected packet follows a normal distribution. So we're good there. We can do normal calculations with this. Has a mean of 2.7 and a standard deviation of 0.08. So I know that the mean of my Splenda packet is 2.17, and the standard deviation of my Splenda packet is going to be 0.08. If Mrs. Sapp selects 4 packets at random, what is the probability that her coffee will taste right? Well, Mrs. Sapp likes between 8.5 and 9 grams of Splenda. So I just introduced this variable X, okay? So X is going to equal grams of Splenda in 4 packets. Okay. So in order to do this, I mean, this is going to be a simple normal CDF here, because really what we're doing here is we have a probability curve. Here is, we want 8.5 and 9. But before I do that, I think let's go ahead and find my mean. So how are we going to find my mean? What is going to be the mean of X? Well, I have 4 packets. Each of those 4 packets averages out to be 2.17. So that means that we're going to have 8.68 grams of Splenda on average. So here is 8.68 in the middle. I'm wanting between 8.5 and 9 grams of Splenda. So here's the area I'm trying to find. In order to do that calculation, I also have to know what the standard deviation of X is. So this is the part that's a little weird. You would think we would want to, we have to remember that we can't take that times 4, well, we're going to take it times 4, but we're going to have to square that first. So that's 0.08 squared plus 0.08 squared plus 0.08 squared and plus, so this is each of the 4 packets that we dump in there. So we're going to have to do that 4 times, okay? And we're going to get a 0.16 out of that. Technically, we could have done 4 times 0.08 squared and got to the same thing. It doesn't really matter. Now, here's where your rubber meets the road on what you're going to do. For time's sake today, we're going to just do a normal CDF and move on with life. My lower boundary is 8.5. My upper boundary is 9. We decided my mean was 8.68, and we decided the standard deviation was 0.16. Okay, so, and because I had these defined previously, I do not have to do any type of subscripts, okay? Everything is good there. So this is 0.848. It's just going out to my calculator and getting that typed in. All right, we got 2 more examples to roll through, and then I'll end your pain today, because I definitely am long-winded today. The diameter C of a randomly selected large drink at a fast food restaurant follows a normal distribution. So again, we're always going to look for that with a mean of 3.96. So if we're defining our variables here, we know the mean of a cup is going to be 3.96. And a standard deviation of 0.01. So that means the standard deviation of my cup is going to be 0.01. The diameter of a lid, L, also follows a normal distribution, so we're good there. So we can go ahead and write that out. The mean of a lid is going to give me 3.98. So it's obviously a little bit, the lid's got to be a little bit bigger than the cup. The standard deviation of my lid is going to be 0.02. So it has a little bit more variability to it. For a lid to fit on a cup, the value of L has to be bigger than the value of C, but not more than 0.06 inches, because then it's going to fall off. Okay, so we're trying to figure out what is the probability that a randomly selected lid will fit on a randomly chosen large drink cup. All right, so again, we're trying to find out what we're trying to find the probability of that difference. So we need something in here. We got to change our variables up a little bit. So we're going to let D equal the difference of my lid minus my cup. So if I take my lid minus my cup, I know that there has to be the left-hand edge of that has to be 0. Okay. And that means that if I do it said it had to be 0.06 in order for it to fit. So that means that this D value, it has to be greater than 0, but less than 0.06. So again, this follows into because I'm putting 2 normal distributions together, my resulting is also going to be a normal distribution, or the difference between those 2 would be. But my problem is, in order to do this calculation, I have to find out what is the mean of my difference, what is the standard deviation of that difference. So this goes into, we have to be able to put 2 groups together. The mean's going to be easy, okay? because that's going to be 3.98 is my lid. .96 is my cup. And so that means the mean difference is going to be 0.02. So my mean difference is going to be 0.02. However, I can accept anything down here to a 0 all the way up to a 0.06 is acceptable. So here's the area that I'm trying to find, because again, the area is the same as my probability. So now I have to find a standard deviation for that. Now the kicker is I have to remember that we're going to add, I have to do it with variances. So that's going to be O1 squared. Actually, we're going to go with O2 squared, my bad. Not that it made any difference, because we're going to end up adding the variances together. Okay, so again, even though it's a subtraction problem, we're adding those variances together. And this is going to give me a 0.0224. So again, just for simplicity's sake, this is where you could find both edges using z-scores and all that fun stuff. I'm going to do a normal CDF in my calculator. My lower boundary is going to be a 0. My upper boundary is going to be a 0.06. We found out the mean of my new distribution is going to be 0.02. And I found out the standard deviation is going to be a 0.0224, which appears to be, well, you're going to have some lids that are bigger than your cup, smaller than your cup size, excuse me. But anyway, sorry, I'm getting back to that babble stage. 0.777 is where that's going to be if we run that normal CDF into our calculator. All right, one more example, and we won't be too late today. Suppose you earn $12 for tutoring, but you spend $8 on dance lessons. You have saved the difference. You save the difference between your income and expenses. The number of hours you spend on each activity varies independently, so we needed that. According to the probability distribution, find your expected savings and the standard deviation of your savings. So again, this is where we have it's a probability distribution. We're going to have a mean of x. X is did it tell me my x is my hours of tutoring? Well, because they put that x there we go. X is going to be tutoring. Y is going to be dance lessons. So we're going to spend on average 5.9. And my standard deviation over here is going to be 0.83. Same thing is going to happen here. I'm going to have hours of dance. So we're going to have mean of y is going to be 2.3. And the standard deviation of y is going to be 1.1. Now the thing is, we're dealing with money. So that means that we have to know what am I going to make from my hours of dance, my hours of tutoring. Okay. So my mean, does it give me any type of variables here? Money from tutoring. Huh. Money spent dancing. Okay. So in reality, all we have to do here is take 5.9 times my $12 per hour. So that means that we're going to get, so we're going to make on average $70 a week from tutoring. The standard deviation of my money tutoring is going to be the same thing. We're going to take that 83 times the $12 and we're going to get 9.96. The mean of my money spent dancing, we are spending $8 an hour to dance. So we're spending 18.4, and the standard deviation of my money dancing is going to be that times 8 to get an 8.8. Now, unfortunately, we haven't even got to what it asked me for because we're talking about the expected. We're putting the difference in that away. So that means that the difference, my pen turned off. The difference of my money dancing minus the money, excuse me, I wrote that backwards. My tutoring money minus my dancing money is going to be equal to then the difference between those two. So we're making $70.80, but we're spending away 18.4. So that means that we're going to have a difference of $52.40. My standard deviation of those two, the money of tutoring minus the money of dancing. Again, we have to remember that we're square rooting this. We can't just do the standard deviations. We have to do the variances. So then I have to take 9.96 and we have to square that. We're going to have 8.8 and we have to square that. And we have to remember, no matter what, even though we're subtracting the two, we're going to add variability to that. Okay, so that ends up being 13.29. And lucky for us, it didn't say interpret, so we don't have to do anything like that. But on average, I'm going to make $52.40. I'm going to be able to stick away after I pay for my dancing lessons. On average, we're going to put $52.40 in the bank. It's going to differ by 13.29 on average per week. All right, that was incredibly long. Let's see here. How do I stop my share? There's the stopping of the share. I'm going to come over here and I'm going to stop the recording.